First of all, I wanted to apologize for the last video. I know I went really fast and I promise we'll go through examples in class, but I didn't have a lot of time. So I just wanted to get through that question. But we will do more examples together and individually in class. The last little bit of notes in this unit are really just some conceptual things. I haven't seen a lot of questions related to this on the AP exam, but I do want to make sure to go through it so that you have at least some exposure to these topics. So the first one being something called selective precipitation. And so what selective precipitation does is it's using anions that form precipitates with only one or a few ions in a mixture in order to separate the metal ions out. So if you take a class in college, I did this in a class called quantitative analysis. And so basically you get a solution that has a whole bunch of ions in it, and you're trying to separate all of the ions to figure out exactly what's in this giant mixture of things. And so in order to do that, you use what's called selective precipitation. So for example, if I give you a solution that has manganese, nickel, copper, and mercury in it, and I want to try to separate all of those ions out into their respective precipitation. So to do that, we're going to employ what's called selective precipitation. So we're going to be adding various compounds that will selectively, given the name, precipitate certain things. And so, for example, the first step is usually to add an acid. And the reason we do that is because if you have a really low pH, which is what's going to happen when you add an acidic solution, it's going to cause the concentration of the sulfide ions to be low, and therefore only the very, very insoluble substances like copper sulfide and mercury sulfide are going to precipitate out. And you can see that based on your Ka values, which we haven't talked about Ka values. We'll talk about them next unit, but they're the same as all the other equilibrium constants that we've talked about so far. They're just looking at acids rather than precipitates or just any substance. So you're looking at an acidic solution. So the first step is to add an acidic solution. For example, if you add H2S. Then once that happens, now we're left with manganese and nickel that we need to separate out. And so then the second step would be to add some hydroxides that will bring the pH back up. And so as it says here on the left side, when the hydroxide ions are added, the hydrogen ion concentration will then be lowered, and the value of the sulfur ion concentration will increase. And because of that increased in ion concentration of the sulfur, that will cause the manganese and the nickel, which are less insoluble than the previous two, it will cause them to precipitate out. Now, the reason this works, I guess the takeaway from this slide would be these 2 points down here. So most insoluble sulfide salts can be precipitated in an acidic solution. And then if you have soluble sulfide salts, they can be precipitated by making the solution slightly basic. So take a solution that has a bunch of ions in it, add an acidic solution, and it will then cause your insoluble sulfides to precipitate out. Whatever's left, you can add a basic solution to it to make it more basic, and that will cause the relatively soluble sulfide salts to then precipitate out, which allows you to separate all of the ions that you have into their precipitates. This slide seems a little bit random, but it's looking at comparing your KSP values to see which precipitate is going to occur first. And so that relates to your selective precipitation a little bit. You will have to do one of these calculations on your test, and I have seen them before on the AP exam. And so we will do more in class, but I'm going to walk you through this example. And so it says a solution containing a copper ion concentration of 1 times 10 to the negative fourth and 2 times 10 to the negative 13th molar lead solution. If a source of iodine is gradually added to the solution, the question is, will lead iodide precipitate first, or will the copper iodide precipitate first? And so you need to then, it's asking you to specify the iodine concentration that's necessary for the precipitation to occur. And so the way that we're going to do that is simply by using the KSP for each value, or the KS and the KSP expression. So step one, as always, is to write the KSP expression, which I did. The concentration of lead 2 plus times the concentration of iodine squared. And I did that exact same thing down here for your copper iodide. Then I'm going to plug in the KSP value, which you were given in the question. I was also given the concentration of the lead in the question, which goes here, and I was given the concentration of the copper in the question, which goes there. So we're left with just the concentration of the iodine that we don't know. Do a little algebra, and for the lead iodide, you get the concentration is 2.6 times 10 to the negative third, and for the copper iodide, you get the concentration is 5.3 times 10 to the negative 8. So what those concentrations mean is that's what concentration for the iodide is needed in order to begin the precipitation. So by comparing these two numbers, because this concentration is lower, we can then make the statement that the copper iodide is going to precipitate first, because it needs less iodide to form that precipitate. And if you were then to go one step further and address the last statement about the concentration needed to begin the precipitation, it would be this. And so again, just to overview the process, you're going to take the two types of precipitates that the question is referring to. You're going to find the concentration of the iodine, or whatever ion it asks you to find, for both of the two precipitates, and whichever one is smaller, that means it needs a lower concentration of that ion in order to begin the precipitation, which in turn means that that precipitate will form first. And so in this case, again, it's copper iodide that will form first. This is a larger schematic diagram to the one a couple slides ago, looking at precipitation, or looking at selective precipitation. And again, this is not something I really think you need to memorize. It's not going to be on your test. It may be a question or two on the final or on the AP exam. So I wouldn't stress out too much about it, but I do want to introduce it to you and show you what sort of how the process works. And so if you look at this schematic, you'll notice that this part right here, H2S, and this part here, adding a base, is what the slides two slides ago was talking about. And I've just expanded this out to look at a much larger solution that has way more ions than the one in a couple slides ago. Now, if there's time after the AP exam and after your final exam, we may do one of these labs just so you can see the process. But I want to walk you through it. And so basically what you're doing is you are taking this solution that has all these ions in it, and you're adding various solutions that will cause certain metal ions to precipitate out by that selective precipitation process. And the next slide goes through the order that's generally used to go about precipitating out. So it goes through and tells you which things are going to precipitate out first. And so if I look at this schematic diagram, the first step is to always add a strong acid. If you add a strong acid, like hydrochloric acid, the insoluble chlorides will precipitate out first. Then you're left with solutions that have sulfides in them. And so because of that, you are then going to add the H2S acid, and in doing that, it will cause your insoluble sulfides to precipitate out, your group 2. Then you're left with groups 3 through 5, which to do that, to get rid of those ions, are going to add a base that increases that pH. Because it increases the pH, it allows the otherwise soluble, but now insoluble compounds to precipitate out. Finally, you are left with groups 4 and 5. And in order to get those to precipitate out, you're going to add something like sodium carbonate, and that will cause your carbonate ions to precipitate out with those metals. And finally, you're left with your group 5, which are usually your alkaline metals. And from there, you can then use a flame test to get rid of, to identify those. And the whole purpose of this is because you're given this giant solution up at the top and you don't know what's in it. And so you're going to go through these 5, 6 steps in order to figure out the identity of all of the metal ions that were added into this unknown solution. And so here is the steps that are usually taken during a quantitative analysis process. So step 1 is to get rid of your insoluble chlorides using the hydrochloric acid. Step 2 is to get rid of your sulfides that are insoluble in an acidic solution, so something that has a high KSP. Step 3 is to precipitate out your sulfides that are insoluble in a basic solution, and that's because they have a lower KSP. Step 4 is to precipitate out your carbonates using the sodium carbonate. And then step 5 is to identify whatever's left, which is going to be your alkali metals and your ammonium ions. Those are things that are really never going to form a precipitate ever. And so the reason that we leave those to last, or the way we identify them once you've left them, is by using a flame test, which you should have done in Chem 1, and hopefully you remember kind of how that works. And based on the flame color, you can see what compounds or what ions are left in your solution. And I would not take too much time stressing over this, especially for your unit test. You definitely will want to review it for the AP exam in May, but I wouldn't stress out too much about it right now. If anything, I would look over this slide only and look at the order of how you would go about using selective precipitation to identify various solutions in a mixture of solutions. But you're never going to see a question that asks you to write an essay explaining this process or anything like that. So I did just want to introduce it to you because it is a requirement that you know about it, but I wouldn't, but you're not going to be asked to, by memory, go through all of these steps.